Evolution, a deliberate yet subliminal process for all but humankind. We cannot wait.
It's one small step for man, one giant leap for man. He's on the move. That's cool.
Coming up in this edition, in 1983, the America's Cup was won by the Australians. The US needed an edge, and they got it with a combination of NASA technology, 3M manufacturing, and a component that was inspired by a rather unlikely contributor. This planet has been around for some 4.5 billion years. It's supposed to last another 5.5 billion, but we're doing our best, it seems, to destroy it long before that time is up. The Kyoto Climate Conference set down guidelines in 2000, but are the people that are running the world taking any notice? Normally, when small aircraft are down, an emergency beacon relays the location of the plane to search teams by way of satellite transmission. But what do these rescue teams do when such beacons fail or simply aren't available? The answer to that question and much more coming up on Making History. French Guiana, December the 10th, 1999. The seconds tick away to blast off for the latest mission of the European Space Agency, celebrating its 25th anniversary. A massive Ariane 5 rocket lifts into orbit the world's most advanced X-ray telescope. It's called Newton, after the famous 18th century British scientist. 3 British-built cameras on board will spend at least 2 years capturing invisible rays from distant galaxies, trying to shed light on the violent origin of the universe and its future. Some of the first X-ray images of exploding stars and black holes have already started streaming back to Earth, free of dust that obscures pictures from even the best optical telescope. The mission is the latest part of the science program of the European Space Agency, a collaboration of 14 countries to fund research in space. The agency was set up in 1975 to promote European cooperation in space research for solely peaceful purposes and help develop advanced technology in Europe. Joint funding made feasible space exploration programs that no single country could afford. All 14 countries contribute to the agency's central funds, according to the size of their GDP. This finances the major scientific missions like Newton. Canada also participates in some programs, and there is collaboration with the American Space Agency, NASA, on others. The Hubble Space Telescope, which has been keeping a steady eye on the stars from 600 kilometers above the Earth for the last decade, is an example of such collaboration. Often thought an American venture, the Hubble carries an ESA-built camera. In return, 15% of the time given to observation goes to European astronomers. This is just one of the space-based observatories ESA is involved with. 5 years after Ulysses became the first spacecraft to fly over the Sun's poles, SOHO was launched in 1995. Sitting between the Earth and the Sun, the SOHO spacecraft has been sending back pictures of the Sun's atmosphere in visible and ultraviolet light. Transatlantic cooperation also extends to space shuttle missions. Since 1993, the shuttle has been regularly carrying up into space a special ESA-built space laboratory called Spacelab. Astronauts and scientists have been able to undertake a range of experiments on weightlessness or microgravity. From 1978 onwards, the ESA has been involved in building and launching communication satellites, now in day-to-day use for television and telecommunications. Some of the early launches, though, were spectacular failures. Yet this didn't stop the rapid development of a satellite market. This is the latest in satellite technology. Using a new laser-link system, the Artemis satellite is designed to handle both communications and navigation data. Satellites are a big growth area within ESA, but they don't come under the centrally funded science programs. Climate change, pollution, and other environmental threats like the recent fires in Southeast Asia are best monitored from space. Envisat is the latest ESA satellite for monitoring and measuring changes in the Earth's oceans, land surface, ice caps, and atmosphere. ESA's Earth Observation Centre near Rome handles data from over 20 satellites. The agency spends most of its budget on contracts awarded to technology and science-based companies in member states. It's a big incentive for member states to get involved in projects like Earth observation and communications. The sun rises on the biggest space project underway today. The International Space Station is being pieced together in orbit and, when finished, will be the size of a modern football stadium. 10 ESA members are collaborating on the project. The agency's main contribution is in building a ferry vehicle which will be launched every year into space, starting in 2002, to take up food and other supplies to the astronauts manning the station. ESA is also building a microgravity laboratory called Columbus, the successor to Spacelab. Like all space agencies, ESA has known disaster as well as triumph over the years. The loss of the Ariane 5 rocket in 1996 and the scientific mission it was carrying was spectacular. But Cluster, a mission to monitor the sun's effect on the Earth's magnetic field, has been revived and is due to blast off again. Mars, the red planet of science fiction. A lifeless desert? Or is it? Is there water under this dusty, rocky surface? We may have the answer soon if the ESA Mars Express lander can probe deep enough. In September of 2000, the ESA would decide on the next generation of scientific missions it would be running. A crucial decision, as all members will be committed to what could be long and costly projects. One is expected to be a mission to Mercury, the hottest planet, being closest to the Sun. The other mission which the European Space Agency will consider is called Gaia, and this is designed to measure accurately the positions of 1 billion stars. By monitoring the positions of stars with unprecedented accuracy, scientists hope the mission will show them how the Milky Way, our galaxy, was formed. While these two missions are being considered, others are already airborne. Right now, the Cassini spacecraft is flying towards Saturn, carrying a European Space Agency probe which will explore one of that planet's moons. Delving into the history and makeup of the universe, as well as monitoring our own environment and helping communications, these are the twin aims, theoretical and practical, of the European Space Agency as it enters its next quarter century. And by July of 2001, space scientists were celebrating the first anniversary of the successful launch of the Cluster mission, which explores the interaction between the Earth and the Sun. Now scientists are for the first time getting detailed information from the magnetosphere, the protective magnetic bubble around the Earth. The nuclear powerhouse that is the Sun is constantly shooting streams of electrically charged particles into space. When this solar wind crashes into the Earth's magnetic field, the magnetosphere, it can break through, damaging orbiting communication satellites and affecting the weather. It's possible to see these solar particles as the aurora borealis, the shimmering lights in the sky near the Earth's magnetic poles. Interest is high as the 4 satellites of the cluster mission begin beaming back data from this cosmic battle zone hundreds of kilometers above our heads. The cluster mission was effectively extended when China announced its first joint venture in space exploration with the European Space Agency. When they are launched at the end of 2002, China's double star satellites will take over some of the experiments currently running on cluster. They joined in cluster at first to share and be involved with the analysis of the data. Then they made a proposal that they could fly some of the cluster instruments on their spacecraft, and as a result, very substantially enhance the science in years to come. ESA says China will not be using the joint mission for military purposes and points out that 2 Chinese rockets will now be used for launching satellites rather than to any aggressive end. To create a yacht that could win back the America's Cup for the United States was an achievement realised by Dennis Conner, a winning team, and the boat Stars and Stripes on February the 4th, 1987. Many enthusiasts felt that the loss of the America's Cup 4 years earlier to the Australians was due to a failure to keep up with the latest technology. In an effort to ensure that the Americans had the fastest boat in the 1991 competition, many changes were made. The design team, led by John Marshall, elected to make use of a new type of drag reduction technology called riblets, developed by NASA's Langley Research Centre and manufactured by the 3M company. These sheets of thin vinyl plastic, placed on the underside of Stars and Stripes, are actually grooved with microscopic scratches called riblets that form perfect triangular peaks and valleys running the entire length of the boat. Rather than having a potentially smooth surface, this is an intentionally rough surface. By placing a small section of the 3M film under the microscope, it's easy to see the riblets and their triangular grooves. The idea of riblets came out of research to modify aircraft so that they move through the air with less resistance. The same researchers found that some sharks have riblet-like skin that allows them to glide effortlessly through the water. Only the fast sharks have this type of skin, the slow ones don't. It was engineer Mike Walsh who originated research into riblets at Langley. The microscopic V-grooves were first studied on machined aluminium plates in this low-speed wind tunnel. 3M then developed a way to put the riblets on vinyl. Test samples of the riblet film were flown by the Boeing Aircraft Company. The reduction of skin friction by riblets is about 6 to 8%, and that transfers directly into savings by the airline industry of roughly $300 million a year. Since it's lighter than paint, it's being considered as an alternative protective coating for aeroplanes. Questions are still to be answered regarding the efficacy of riblets, but they are being considered as coatings for natural gas pipelines, submarines, and race cars. NASA's riblet technology, a high-tech solution that helps keep America on a competitive edge. Recently, floods have had a devastating impact around the world. In 1999, 30,000 died when a cyclone hit India. And in March of 2000, hundreds of thousands of people in Mozambique were stranded by floods caused by a massive cyclone. Extreme weather around the globe has fueled speculation that the world is beginning to see real long-term changes in climate. Global warming caused by the buildup of greenhouse gases is thought to be the cause. Global warming is caused by a blanket of gases that envelop the Earth, raising its temperature. The biggest culprit is carbon dioxide, mostly given off when oil, gas and coal or fossil fuels are burned. Britain has recently seen extraordinary heavy rainfall and widespread flooding. While wary of blaming global warming for a specific weather event, climatologists see a pattern to the floods. CO2 emissions for energy use increased 12-fold from 1900 to 1990. The 8 richest countries in the world, the G8, were responsible for nearly half the world total of CO2 emissions in 1990. In 1997, in Kyoto, nail-biting negotiations finally led industrialized countries to agreeing to cut their CO2 emissions by an average of 5% by 2008 to 2012. The Hague Conference is widely seen as the acid test of the resolve of these nations to actually meet this deadline. The Alaskan tundra is a natural wilderness and at first sight appears untouched by predatory humans or the effects of climate change. But here even subtle temperature rises caused by global warming are already laying waste vast areas of virgin forest. We found that habitat all over the world is threatened by global warming, and the speed with which that warming occurs is going to be critical to the survival. The temperature change doesn't kill the trees. The effect is more insidious. A parasite called the bark beetle is multiplying to an astonishing degree, destroying 90% of the trees in some areas of Alaska. Insects, being cold-blooded, can complete their life cycle twice as fast when the weather gets warmer. The bark beetle, which normally has a 2-year life cycle, now goes through its life cycle in 1 year. Forests are becoming a controversial factor in the climate change debate at The Hague. Because soil and vegetation absorb carbon dioxide, some countries are hoping to use them as a way to avoid reducing their CO2 emissions. Countries like the United States propose buying up forest at home or abroad and offsetting the carbon soaked up by the trees against its CO2 emission quota. It's known as the carbon sink argument. Environmental groups are very wary. There's a lot of uncertainty about how much the forest can actually absorb and what will happen in the future. In Tasmania, Japanese companies are cutting down ancient forest and replanting the area with fast-growing plantations, claiming credit for creating a new carbon sink. Local environmentalists see this as a commercial scam which will only exacerbate CO2 emission. The actual clearing process to establish those plantations, the burning that results after the forest clearance, and the ongoing logging for pulp production is contributing to further production of carbon dioxide. Another way some leading industrial countries hope to avoid actually cutting their greenhouse gas emissions is by buying up other people's quotas. Climate change, as well as modern intensive farming, is blamed for the steady decline in the number of field birds like linnets and skylarks in Britain, for example. The Royal Society for the Protection of Birds is taking a keen interest in the Hague Conference and the wrangles over carbon trading. Far from the political discussions in The Hague are the snowy Altai Mountains in Mongolia, home to one of the most endangered animals on Earth. There are only about 7,000 snow leopards left in the world. Now, Mongolian Buddhist monks are helping to save this beautiful animal from extinction. Buddhism was suppressed during 65 years of communist rule in Mongolia. Since the Soviet Union collapsed in 1990, the faith has flourished. Buddhists have now reintroduced a traditional ban on hunting the snow leopard and logging sacred sites. It's an example of the Sacred Gifts Initiative, a partnership between the International Conservation Organization, WWF, and 11 of the world's major religions to promote local conservation. Another sacred gift focuses on cleaning up toxic waste in Lake Erie, one of the Great Lakes of North America. Run by local nuns, Earth Force is an educational program for 50,000 school children from the US state of Pennsylvania. If governments are unable to come up with a constructive approach to resolving the Earth's problems, then these local initiatives are the only hope. Their job is search and rescue, but until the 1980s, these crews often had little to go on. This changed when locator beacons became mandatory on small boats and planes. In an emergency, the beacons emit a signal that is picked up by a series of satellites and relayed to search and rescue forces. This effort has saved more than 3,000 lives over the past 10 years, but in situations where a locator beacon doesn't activate, rescue teams are again forced to cover sometimes thousands of kilometres hoping to locate the craft before it's too late. Looking for a way to increase the odds of success in these beaconless searches, researchers from NASA's Goddard Space Flight Center made their way into an isolated, heavily forested area near San Francisco. As part of an ongoing experiment, their mission was to drop off a plane wreck. This particular wreckage was positioned just down a dirt road from another which had been hauled in some time ago. Both had been placed intentionally below a heavy canopy of trees to see if a system called synthetic aperture radar, or SAR, aboard a DC-8 could detect the wrecks through the foliage. The goal was to evaluate whether this special type of radar, traditionally used in geographic and forestry studies, might also be a useful tool for search and rescue teams in crises where no locator beacon information is available, or where bad weather or trees make it impossible to see a downed plane from the air. Upon completion of a flight, the images produced by the SAR are transferred to NASA Goddard for final processing and analysis. The bright spots are things on the ground that could be the target wrecks. By filtering out features known to be part of the everyday landscape, such as buildings and towers, the location of each wreck is isolated. In bad conditions, it's not uncommon for the lives of rescuers themselves to be lost. It's hoped that searches augmented by the new synthetic aperture technology will save the lives of the rescued and rescuers alike.
It's one small step for man, one giant leap for mankind.
It's on the move. That's cool.